What's up everyone, welcome back to Just Finished Coding. This is part 3 of our object-oriented programming series on Python, so let's get coding.
Just finished coding.
Now, quick interjection here, if you've not watched parts 1 and 2 of this series, please watch them before you come here, because for this video to actually make sense, you need to have a foundational understanding of classes and objects. I'll leave a card for you right here. Please watch those videos and then come right back. Now, if you're still here, I'm going to assume that you've watched parts 1 and 2, in which case you can proceed with this tutorial. In this video, we'll be talking about some special kind of methods which are constructors and destructors or garbage collectors. And then we'll also talk about how you can overload your methods as well as your constructor using some tricks that I'll be sharing with you in this video. So let's get right into it. So right here you can see that I've typed out a simple class, and the class is called employee and it's not really inheriting from anywhere. And you can see that we have two methods inside it. The first one, you might actually be familiar with it, the def__init method. And the second one, you might not be familiar with it and you might be seeing it for the first time. And this is the def__del method, okay? And these two methods are probably the most special methods within a class, okay? So the first method, which is the def_init method, has a special name called a constructor. And you might be familiar with the name if you've programmed in Java or some other languages. But just keep in mind that this is called a constructor. And what this is actually used to do is to actually initialize the what you'd call as data members in Java, or what you'd call attributes. Okay, so this is used to initialize the attributes of every single object. While the destructor method or the garbage collector method, which is this def__del method, is actually used when the object is being deleted. And if the object is actually being deleted, it can either be done manually by the coder himself or automatically at the end of a program. So if I just leave it as it is, okay, so I just let this program just execute some random code like print hello world or something. I'm not going to do it, but just assume I do. At the end of that, when you like have this have these lines of code which says process finished with exit code 1 or whatever, like when your process finishes, you would actually have this destructor method execute automatically, assuming that you've declared an object of that particular class. So if you've not, you wouldn't really have anything. And in case you have declared an object, you have formed a new object, you've like allocated the space in the memory. In that case, this destructor method is going to execute automatically, because the Python interpreter, I think, actually deletes every single object at the end of the program. Unless, of course, you're saving stuff, which I'll get into in a whole different video. But just keep in mind that things are deleted automatically. So now, since you are familiar with constructors, let me actually show you how these garbage collectors or destructor methods actually work. Okay, so I'm going to head over to some new space, and here's what I'm going to do. So I'm just going to declare an object E, which is an object of the class employee. And since our def__init method does not have like any input parameters, I'm just going to leave it as it is. Now, right after this, I'm just going to end the program. I'm going to terminate it. So I'm just going to leave the code at this. Now, when I actually click run, you can see that we've printed out by, and that is exactly what we had within our garbage collector or destructor method. So like I mentioned, the object is going to be deleted right after, you actually finish your program. So this is really what is executing at that particular time. Now, if you actually want something to happen at the end of, let's just say, every single deletion, like whenever your object is deleted, you want something to happen, then this is your go-to method for that. And this is how you can get stuff to happen when you delete your objects, in case you want to have something. And this isn't really a compulsory method, and none of the methods are compulsory, including your def_init method. But usually we do have something inside of them, because we usually have attributes for every single object. So most of the time you won't see this method though, because it's not used as much, mainly since like the Python interpreter itself deletes the objects. But I just think it's pretty cool, and I do use it in some of my projects. Now let's talk about overloading methods and constructors. So I'm going to remove that run window and I'm going to delete all of this code. And whenever you usually think about the word overloading, what it really means is that we have two methods with the exact same name and they have like a different input. Okay, so I could just have another constructor right here like def underscore underscore init, and I'm going to just have two input parameters instead of, or let's just say I have one input parameter instead of 0. So now I just put in another parameter which is going to be called age, and I'm just going to say self.age equals to age, and I'm just going to print out the string of self.age. There we are. Okay, and now we actually have two methods with the exact same name, and already you can see the Python, my IDE is showing some bugs right there, and that's because Python does not allow you to overload methods by default. And if I actually just run this program without even calling in an object, you would see that there are no errors. But if I actually call in an object, let's just say equals employee, and I'm going to enter in the age of that employee, let's just say 35. Okay, and I leave it as it is. I just like enter in a new line there and I just run this, for example. Now you can see that we have 35 set up. But if I remove that parameter right now, and now I just save this and I click run, now you can see we have like some errors which are popping up. And you may think, well, why doesn't it just think, well, if there is like 0 parameters, then we're just going to have a self.name. And if there's, well, one parameter, which is the age, then we're going to have a self.age as well. But unfortunately, that's not how Python works. That's how languages like Java and C++ work. But you can't do that in Python. You literally cannot overload methods and constructors. And I think most of the time it takes in the last one, but don't count me in that, okay? Now, luckily for us, there is a way through which you can get around this, and you could do that by utilizing something which are called optional parameters. So delete this init method which we are trying to overload, and what you can do is right after this self parameter which we had, you could put in a comma and add the age parameter. But we're not going to leave it this way. What we're going to do is after age, we're going to put in an equals to and just type in something which is called a default value. In this case, I'm just going to be setting the default value to be false, but really you could have this even as a literal. So you can type in something like, 35 or 40, or you could type in a string, whatever you want. I'm just going to type in false, okay? Now what you can do is right after, the self.name equals to Dave, you could just type in an if, okay, a simple condition statement. And now you can say if age is, and you could just type in false. Well, in this case, we're just going to have in like a self.name and I'm just going to pass. But if our age, if we did enter in an age, for example, we could just say print out and I'm just going to say age. Okay, so, or let me just declare in an attribute. So I'm just going to say self.age equals to age, and I'm just going to print out self.age. So the string of self.age. Perfect. Now what's going to happen is that if we actually entered in an age, then this else statement is going to happen. And if we did not enter in an age, it's going to assume this default value and we're just going to pass through and not really do anything. Now, in case you're confused about why I use is, it's just because false isn't like a normal literal, like an integer or a string. And I do use is with Boolean values, but if you just put in an equals to, I think that'll work fine. Don't count me on that though. I just use an is most of the time. And is is generally what you'll be using with like false, or in case you typed in none, for example. But just understand the idea for now. So once you have this in place, now if we run the program without having like any parameters, now it would actually have this neat thing which says process finished with 0 code in whatever IDE you're using. And in case like you did enter in the age, so in our case, let me just enter 35. Now if we run the program, you can see that we actually printed out 35 and we've effectively bypassed the system of overloading, which Python does not allow. And this is pretty cool, and I do hope that you found this tutorial helpful and you actually do use what I've taught you right here when you do come across this problem. And that's it, we'll be coding in this video. If you've enjoyed this video, please make sure you leave a like and also don't forget to subscribe and turn on the notification bell. Thank you so much for watching and I'll see you in the next video.